Hi guys, welcome to another episode of Intelligence Lectures. So today we'll be looking at Euclidean geometry because one of you guys requested me to do a Euclidean geometric figure. So yeah, now here we are. Euclidean geometry is a geometry of lines, circles, angles, triangles. Yeah, that's Euclidean geometry. So before I can get right into it, please subscribe to my channel and also hit on the notification bell below so that you'll be the first one to know every time I upload a new video. And also you can follow me on Instagram, it's Intelligence, um, and you can ask me questions there and I'll be more than happy to assist you guys, or you can put your questions um, in the comment section below and I'll do by all means to answer them as soon as I can. So let me just get right into the video before I waste much of your time. So now um, as you can see a structure in front of us. I believe most of you guys are familiar with it because I've seen it in it was depicted from a 2019 exam paper which was written in November. So yeah, most of you guys have seen it, and if ever you had troubles solving it, now you are at the right place. So without any waste of time, let me just get right into it. Okay, since now I'm not gonna do a lot of theorems and all, you know, you should know them by heart. Okay, in fact, let me just give you guys tips on how to excel in geometry. Number one, I'm just assisting you. If there are other things which you know, you might as well just tell me that I missed this, I missed that. So number one is I expect you guys to know all the theorems. I expect you guys to know all the theorems by heart. You should know them, you should live them. Every time you should know the theorems, all the geometric theorems, you should know all of them by heart. And another point is I expect you guys to know all the properties of lines. I expect you guys to know all the properties of lines, and you should know them by heart as well. And again, I expect you guys to know all the properties of triangles. I expect you guys to know properties of triangles. And lastly, I expect you guys to know all the properties of a cyclic quadrilateral. I expect you guys to know all the properties of a cyclic quadrilateral. So yeah, if you know all these properties over here, I believe you're gonna be good in solving geometric figures, getting all the angles, and solving everything. So let me not waste time trying to explain these things, but yeah, you should know them by heart. If you can't know them, please shout out so that I can make a video on geometric theorems and so that we can all understand each other here. So number one, when you see a geometric figure, the first thing to do is to read the instructions. You should always read all the instructions. Don't even skip a single instruction. For instance, here with this diagram, it says PQRS. PQRS is a cyclic quadrilateral, which means all the theorems of all the properties of cyclic quadrilateral should come up in your head. And if ever you feel like you can forget them, just write them down at the back of your answer sheet so that you're not gonna forget all the properties of a cyclic quadrilateral. So here you can see that now they say P. You can see that this line and this line, since they have a propeller arrow, I can call it a propeller arrow, since they have a single propeller arrow. So now they symbolize that they are parallel. And again, as you can see, these ones, they have a double propeller arrow. It means they are parallel as well. So you should know all the properties of lines. I believe if you see this, even if they didn't specify it in your instructions, but you can see that it has these kind of lines, I believe you guys will know that they are parallel. And again, sometimes you might find out that there's this line, maybe it has something like this or this. This means that they are equal, not parallel. Don't mix the two. It means they are equal. So okay, I believe, okay, now you can see Q1 is 100 degrees, as well as S2 is 136 degrees. So I expect you guys to just see all these things. So now let's focus on solving. Now they're saying we should determine with reasons. I even underlined it with a red marker, with reasons, the sizes of R. Okay, so now we have to determine the size of R with reasons. It means they need a value, a size. Maybe let's just say it's 100 degrees, let's just say it's 136 degrees. They need that number, not it's equal to P, not it's equal to K1, no, it's equal to whatever degree it may be equal to. So in geometry we don't really have a memorandum, so you can just answer the way you feel like. As long as your reasons make sense, you're gonna get a mark. So I'm gonna use the longer route, or I'm just gonna use the route which I think most of people can relate to. So I'm gonna start at, okay, and again it's advisable to start with an angle that has a size. Maybe start with 136 or start with 100 degrees. So just start maybe with an angle that has a size, or you can just choose to start wherever you feel like. It's still okay, it's acceptable, but let me just start where there's a size. Okay, let me just start at Q1 because I know it has a size, so it's gonna make my job easier to find R. So I can start by saying Q1, angle Q1 plus W, angle Q1 plus W is equal to 180 degrees. So these lines, I didn't draw them quite well, but they are parallel. I mean, you can see that they're not on my diagram, but if you can check in the question paper that was written last year, they are really parallel. I just failed to draw them well, but yeah. So it's equal to this angle, and this angle is equal to 180 degrees, because we know that core interior angles, they are equal to 180 degrees. Some people, yes, they write equal to 180 degrees. It depends on the school you come from or how they taught you. So I don't want to write that, but if you are taught to write it, then write it. So there it's equal to 180 degrees. That's what we know. So now we know now we're just substituting everything. Q1 is 100 degrees plus angle W is 180 degrees. 180 degrees. So these 100 will just cross over, and it will change its sign. It will become angle W being equal to 80 degrees, since this 100 will go over there, and it will be 180 minus 100. So yeah, this is our angle W. Again, now since we found angle W, then we know that angle W, let me just write it over here, it's 80. Now we know that angle W is equal to angle K2. How is it? These two lines are parallel, and since these two lines are parallel, we've got this line over here. It makes a Z. it makes a Z or a Z. So now we know that, we have a Z there, this angle and this angle, which are these two angles. They are alternating angles. The one we used here as co-interior, those ones that form C, this angle and this angle, it's like these two. See, if these lines are parallel, of course. So yeah, now we arrived at this angle, and we're gonna say angle W is equal to angle K2. Reason being, they are alternating angles. So they are equal. So this is straightforward. I think. Okay, let me write it like this. Let me just say angle K2 is equal to W. They are alternating angles. This angle is equal to that one. I believe you can all see that. And then from there we can say angle K2, this angle. Okay, let me also write it here. Let me use a different one. We can say this angle over here, we found it's 80 as well. It's 80 degrees. So now we can say angle K2 plus angle K1 equals to 180 degrees. Reason being, adjacent angles on a straight line. Adjacent angles on a straight line, so they equate to 180 degrees. So since we've got this and we know the size of K2, then it makes our job simpler to say now angle K1. Okay, let me just say, now it makes our job simpler to say angle K2 is 80. Now we're just substituting. It's 80 plus K1, which is unknown, is 180 degrees. And now we can say K1 is equal to 100 degrees. Now we know that let me use this one. Now we know that K1 is 100 degrees because they add up to 180 degrees. So we know that K1 is 180. Then now we go to now we find R. We know that angle K1 plus angle R equals to 180 degrees. Why? These two lines are parallel and there's a line there, so they form a C, which is co-interior angles. And we know that co-interior angles add up to 180 degrees. So now it makes our job even more simpler, because now we're just substituting, and K1, we know that it's 100 plus R is 180 degrees, which means angle R is equal to 80 degrees. Now we found the size of R. So now we can come over here and write our 100 degrees there. Yeah, so we can write 100 degrees over there to show that now we found it's 80. I'm sorry. Now we can say we know that it's 80 degrees. So since we know that now this angle is 80 degrees, okay, let me just, I believe This board is so small, so I have to erase. So okay, so now we found angle R. So now they say we should find angle P, and again they told us that this PQRS is a cyclic quadrilateral, so it means we're just gonna apply the rules of a cyclic quad. Oh, I forgot to write U1, 2, and 3. Forgive me for that. So now they're saying we should find the size of P. When we find the size of P, since we know that this is a cyclic quadrilateral, then it makes our job simple to say angle R plus angle P, they equate to 180 degrees. Why? Opposite angles of a cyclic quad. Opposite angles of a cyclic quad. You can say opposite angles of a cyclic quad equals to 180 degrees, but for this case I'll just write opposite angles of a cyclic quad. It depends on how they taught you and maybe the region you're from. So again, now we're just substituting 80 degrees plus P equals to 180 degrees, which gives us angle P being 100 degrees. This one is the simplest since you found angle R. So now we know that angle P is 100 degrees. So now we're going to the size of Q2. It means this one over there. So let me erase. If I'm moving too fast, please pause the video, watch it over again, know all the reasons, and if ever I've made a mistake, you can just contact me, Euclidean, that's my Instagram, and then we'll talk. So, and if you need any assistance, please seek help. Just don't die alone, please. Don't die alone. Ask for help. Go out there, find help. So yeah. Now we are going to angle Q2. Now to find angle Q2, we have to understand again the properties of a cyclic quadrilateral. So okay, it's not gonna be, it's also simple. Let me just get into it. Now to find Q2, we have to say angle Q2 plus angle Q1, they equate to angle S2. Why? Exterior angle of a cyclic quad. You can say exterior angle of a cyclic quadrilateral or whatever, however they taught you, but exterior angle of a cyclic quad. So exterior angle of a cyclic quad, you can say, I've seen some people extending it to say exterior angle of a cyclic quad equals to the interior opposite angle. You can do that, it's acceptable, but it depends on how they taught you. Exterior angle of a cyclic quad, just leave it there, or exterior angle of a cyclic quad equals to the interior opposite angle. So now, since we know that, because when I say angle Q1 and Q2, I'm talking about this whole angle here, this whole angle over there, which is angle Q. It's Q1 and Q2 combined. Yes, combined. So since we know angle Q1, so it's just gonna be angle Q2 plus, now we're substituting 100 degrees equals to 136 degrees. So this one will move over there, then angle Q2 is equal to 36 degrees. Simple as that. That's the most simple question you can ever get in geometry. So since we're done with that, let me just jot it down. So this angle over here is 36 degrees. So since we found Q2, now let's move to U2. I believe this is U2. Let me just do it like this to show that this one is U2. This part over here, it's U2. So to find U2, if it wasn't because of my board, I could have not been erasing, but my board is small. So Q2, to find Q2, U2, to find U2, here we have to understand the properties of triangles, because as you can see, this is a triangle. It's a triangle. Now we are dealing with triangles all of a sudden, and lines, so you have to understand all those properties. So you can say angle U2 is equal to angle PUW, which means this angle over here, they are equal. Reason being, opposite angles are equal. I don't know how you guys reason based on this, or you can say vertical angles equal. I've seen some people writing vertical angles congruent. Vertical angles congruent. It depends on the region you're from and how they taught you at school. But yeah, if opposite angles are equal, or vertical angles are equal, or vertical angles are congruent. However you reason, that's your best reason. You should use that one, the one you've been taught. So now, since we said this one is equal to that one, now we can say angle PUW equals to angle Q2 plus angle P. Reason being, exterior angle of triangle PQU. Exterior angle of a triangle PQU. So it depends also on your reasoning, but for this example I'm going to use this one, since you can see that this angle over here PUW is equal to this one plus this one, is the exterior angle of this triangle PQU. So it means it's equal to this one plus that one. So now you can say angle PUW equals to, and Q2, I believe we have Q2, it's 36, plus P is 100. So now it means it's 136 degrees. That's our angle PUW. So now remember that we have to find angle U2. So to find angle U2, like we did it here, angle P, okay, let me just say angle U2 is equal to PUW. Reason being, proven. You can say proven. I've seen some people writing proved. It depends on where you come from as well and how you were taught. So this one is equal to that one. Then it makes our job more easier to say U2 is equal to 136 degrees. So now we found all the angles we needed, and now we found all the angles we needed. Let me just write it here, 136 degrees. 136 degrees. Now we found all the angles we needed, and I believe this video has been very productive and useful. If you have any questions, you know what to do, Academicians, or you can put it in the comment section below. Please don't forget to subscribe and like my video, or you can even share it if you like it that much, so that other people will learn as well, and I will know that my efforts were not in vain. So thank you guys for your attention. Till we meet next time, this is Academicians Lectures. Thank you.